Water. As Earth's crust cooled and solidified, water vapor condensed. It rained for 100 million years and the oceans formed. For many years, most scientists believed that water was brought to Earth by meteorites in the early solar system. But that cannot explain the large amount of water in our oceans. There must be an additional source. While this is still a good hypothesis, other hypotheses have been proposed more recently. Lunar samples taken during the Apollo missions of the 1960s and 1970s showed that the water found on lunar soil particles match water particles on Earth. This tells us that the Moon and Earth probably got water from the same source, and not just from meteorites. This discovery suggests additional hypotheses about where Earth got its water. What is the source of our water? Could water vapor have been carried from the Sun to Earth and its moon by solar wind? Could it have been carried to Earth as the planets formed from other planets, such as Jupiter or Saturn, when their early orbits crossed Earth's path? There are several hypotheses that could explain where our water originated. Our water probably has more than one original source. 3/4 of Earth's surface is submerged in water. Water is fundamental to life on Earth. Why? A water molecule consists of two hydrogen atoms covalently bonded to one oxygen atom. Like all molecules, water is electrically neutral. However, its oxygen atom more strongly attracts electrons than its hydrogen atoms. That results in its electrons being more concentrated on the oxygen side of the atom than the hydrogen side. That results in the oxygen side of a water molecule being slightly negative and its hydrogen side being slightly positive. This results in water being a polar molecule, since it has a positive and a negative pole. This is important to the behavior of water and its impact on life. The positive hydrogen side of one molecule is attracted to the negative oxygen side of other molecules. This results in the formation of networks of hydrogen bonds. Hydrogen bonds form between molecules, so they're called intermolecular bonds. In contrast, the covalent bonds that form molecules are intramolecular bonds, and they are much stronger. The polarity of individual water molecules gives rise to intermolecular bonding, which is the basis for many emergent properties of water and many characteristics of living things. Life began in water, and biochemistry takes place in water. Water shapes life on Earth. Cohesion is when water molecules are attracted to one another. Adhesion is when water molecules are attracted to other molecules. A high specific heat means that water resists changes in temperature. It's a universal solvent, which means it dissolves most ionic compounds, and ice floats. Water's solid form, ice, is less dense than its liquid form. We see evidence of adhesion and cohesion when we look at a meniscus of water. The top of a column of water is not flat. It is pulled up the sides of a glass cylinder, forming a cup-shaped meniscus. Adhesion results in water molecules being attracted to the polar glass. Cohesion results in water being attracted to one another, pulling the water from the center to the sides of the tube. Some examples of adhesion and cohesion include capillary action, plants pulling water up from roots to leaves, large drops of water, ripples and waves, and surface tension. Water has a very high specific heat, which means it takes a lot of energy to raise the temperature of water even a few degrees. This means that temperature on Earth's surface is moderated by its water. The temperature doesn't get too hot or cold. Why is this important in the development of life on Earth? Water is sometimes referred to as the universal solvent because of its ability to dissolve most compounds. Ionic compounds dissociate in water, and water forms shells around dissolved ions. Water with dissolved ions has always been the solvent of biochemical reactions. Life's chemical reactions need to occur in solution. Nutrients can dissolve in water, allowing chemical reactions to occur. The dissolving of compounds in water also lowers its freezing point. The hydrogen bonds that are fluid in liquid water, allowing molecules to slide past one another, are static in solid water. Ice has a crystal lattice structure that holds the molecules in place, farther apart. Therefore, ice is less dense than liquid water. The ice cubes have lower density than the cold water surrounding them, so they float.